the principal focus, like this. Make sure that you always indicate the arrows. So whenever drawing a ray diagram, whether it is on a piece of a rough diagram or it is a scale ray diagram, by a scale ray diagram we say that you must draw it on the graph paper. A scale ray diagram, an accurate diagram. On the other side, a ray of light which is coming from the head of the object for the convex mirror appears to come from a point. So you connect using a straight line and then continue like that. Yes. So behind the mirror it is dotted. In front of the mirror it is not dotted. Likewise, that is the first rule. The second rule says that a ray of light which passes through the center of curvature is reflected back along the same path. In other words, if it is starting from the same point for the concave mirror, and it is passing through the center of curvature, like this, it is going in that direction. It is going to go until when it meets this mirror here. So once it meets it at 90 degrees. In other words, it is normal. That's why it goes back along the same path, like that. So where these two rays here meet, at this point here, since they're coming from the head of the object, the image is also upside down like that. They're coming from the head, they're going back, they're meeting at the head, like that. So that is on the side of the concave mirror. Likewise, on the side of the convex mirror, it is the same thing. You draw a line starting from the head and connect to the center of curvature, this point here. So when it comes like this, remember behind is supposed to be a dotted line. So it goes like that, passes through the center of curvature. And where they meet, they're meeting at this point here. Yes. Where they meet is where the image is formed. And it must also be dotted like that.
I have a question.
So this one is the image. Yes, please.
On the concave mirror, it's upside down, but on the convex mirror, it's upright. What makes it about? What's about?
Yes, that's what I'm saying, is that it is the rules that we follow. Now, one thing that we need to note as well is this, that for the convex mirror, for the diverging mirror, the image formed is always upright, always upright. But for the concave, the image sometimes is inverted, sometimes it is upright. What is the difference? Yeah. So that is the difference. Maybe the last one is this. The last rule is this, that a ray of light which is passing through F, like this, that ray is opposite to these ones here. It is opposite to these. In other words, if it is passing through F, then it is reflected as a ray which is parallel to the principal axis, like that. On the other side, again, a ray which is passing through F is reflected as a parallel ray. So for this one, you can simply look at this one here. This one here. Like that. So Stacy, let me show you another thing. In case we are having a concave mirror like this, we have our F, and then we have our 2F. If the object is here at this point, where is the image formed? Still following the same rules. I said that if we follow the rules, you said that a ray of light is close and parallel. It must go through F, like this. Likewise, a ray of light which is passing through F, the center of curvature like this, it is going to go to the mirror like that. And since it is passing through the F, the 2F, the center of curvature, it is going to be reflected back along the same path. So when you look at this side here, these two rays here, this one and this one, they're not going to meet anywhere. If they're not going to meet anywhere, then what you do, you simply extrapolate, you extend these ones here, like that. And you'll find that the two will be meeting at that point there. And where they meet, that's where the image is formed. So you can see that this one is upright, whereas for this one here that we had previously,
is upside down.
This one is upside down. So that is the difference between the two. And one thing that you need to remember always is that when do we form an upright image for the convex, for the concave?
Yes, when?
When do we get to that? What is the condition for that? The condition is only one. The condition is here. In other words, if the object is between F and the mirror, if the object is between F and the mirror, then always the image is upright. It is magnified. It is virtual. Always. So those are the conditions for that. Those are the conditions for that. Now I want us to try out something, but this time around on a graph paper. On a graph paper. Let me write the question as also write it down. So question, an object 2 centimeters.
So right.
Yeah, we read the question. An object 2 centimeters high stands perpendicularly on the principal axis uh, 20 centimeters away from the pole of the concave. Of focal length 20 centimeters. Yes, are we done?
Yes.
Perfect.
On the next page. So part A, use a scale diagram to locate the position of the image.
Teacher, you first.
But I'm writing, you can see. Use a scale diagram to locate the position of the image. And then part B, determine its Roman 1 height, and then Roman 2 magnification. So that is the question for discussion. For me, I don't have a graph paper, but for you, you should use a graph paper.
Yes.
Yes, are we done?
Yes.
Okay.
Yes.
Okay. So you can have a simple sketch. You can have a simple sketch. The question says that we have a concave mirror, and they're saying that the object is 2 centimeters high, Maybe let me draw on the next page because here it is
Small.
having small space. So you can also be having your own sketch there.
Yes, teacher.
When you're drawing the sketch, you can use freehand, yeah,
Yes.
because you're just doing a rough diagram. So you're having a concave mirror. F is at 10 centimeters. Remember your R is equal to F, which is equal to 2 times 10, which gives us 20 centimeters. So 20 centimeters, that's to have 20 centimeters.
To F.
20 centimeters, you have to F.
To F.
Yes. And then our object is at 20 centimeters. Our U is equal to 20 centimeters. They want us to get the image distance, the image position. So this is 2 centimeters high. So that is our simple sketch. Remember the rules say, let me wait for it to complete.
Image height. So for me, I'm done.
Awesome.
Okay. Okay. So the rules are simple. We say that the first rule says that a ray of light which is close and parallel is reflected through F, like this. Then another ray of light which is passing through to F is here. But all the rays must begin from the head, which is here. So it goes like this, and then it comes back to the same position. So where they meet, they're meeting at this point here. Where they meet, that's where the image is going to be formed, like that. So you can draw that simple sketch. Then I show you what to do on the graph.
Done.
So where is the
image?
Yes. Oh, it's here. It's
Yes,
in
I've
black.
used the black. I've used the black, yes. The image is there.
Mm. I'm done.
Okay. So you get your graph paper, you get a pencil,
Pencil.
and then a ruler, and then we start.
Yes.
Okay. So on the graph paper, of course, you can use landscape. Landscape, I mean the longest side of the graph paper when it is horizontal. Or you can use portrait, you know that language, computer language. Any side
Yes.
that you want, it is fine. Now, if you look at this
Yes.
diagram here, the reason that's why we have had a sketch is to help us note where is the image, where is the object, on which side of the mirror are they. From this diagram, we're seeing that the two are on the left-hand side. And in other words, it means that in case this was a graph paper, we would have left out all this space here for nothing. Would have left out that space for nothing. But since we have now found out that using our sketch, we can simply draw a graph which is quite big and accommodating all that space that we have. So this is what I mean. If this is our graph paper, on the graph, in the middle you draw a horizontal line, and then this other side, yes, almost at the end of the right hand side of the graph paper, you draw a vertical line like this. Then you also indicate that you have a concave mirror like this.
So we do the concrete compass.
You can use a compass, you can use a freehand, it is fine. Just do a small diagram.
Okay.
Yes, that concave mirror there simply shows us that the concave mirror position is there. That's why we use that line to magnify.
Teacher, the line is the middle.
Yes?
The line is supposed to be in the middle.
Which line? The vertical line?
The horizontal line is supposed to be
Yes,
in the middle.
the horizontal do it in the middle because there's the object is up, the image is down. So we need that space above and below the line.
Yes.
That's why we have to draw a simple sketch first to tell us where is the image, where is the object. So you can see that this vertical line is almost the right-hand side because the space behind there is not needed, as we have seen on the graph, on the sketch, sorry.
Yes, teacher.
Yes, so in case you're done, we're going to be very careful and we count those small squares on the graph paper. So you count 10 small squares, you draw a mark. You count another 10 small squares, you draw a mark. Another 10 small squares, you draw a mark. Another 10 small squares like that. So each of those 10 small squares represent 2 centimeters. 2 centimeters long. Actually, when you even put there a ruler, you can see that it is actually 2 centimeters. But some graph papers, they also continue to bisect those spaces into small squares. So sometimes they are 20, sometimes they are 10. But the normal graph papers that we use, even at UNEB, at school, 10 small squares represent 2 centimeters. If you have done that, do the same for the vertical. After every 10 small squares, you draw a line. 10 small squares, a line. Even down, 10 small squares, like that.
Okay.
We are done.
Yes, teacher.
So when you look at this diagram once again, this diagram here, we can see that the focal point is at 10, the center of curvature is at 20, even the object is also at 20. So if you can say that this space here can represent 10 centimeters. If the 10 small squares, it can represent 10 like that, or it can even represent 2 centimeters, or it can even represent 5 centimeters. There's no problem, but always draw a bigger diagram. What I mean is this, that assuming that this is our graph that you have drawn and those divisions are 10 small squares each, you can begin by testing and use 2 centimeters to represent 2 centimeters. For example, here I may say, if my scale is 2, from 2 I go to 4, I go to 6, I go to 8, I go to 10, and so on. If I don't reach the point where the object is, then that scale, that difference, 2 centimeters. So that scale of using 2 does not work, which means that I have to use another scale. So the scale that I'm going to use now, I'm going to test 5. You must test until where the farthest distance that you want is. So if I test 5, I have 5. I have 5, 10, 15, 20, 25. So the farthest distance that I want is 20, and it is covered there. So I'll use a scale of 5, 5, 5, 5. Likewise, upwards, downwards, do the same. We can say that we have 2, 4, like that. 2, 4, like that. Remember, my height of the object was 2 centimeters, so the 2 is covered. Or you can even use 1. You can even use a difference of 1, 1, 1, 1. 1, 1, 1, like that. For example, in case I use 1, 1, I'll use from 0, I go to 1, 2. From 0, I go to 1, 2. So since my height of the object was 2 centimeters, even the 2 is also covered there. Now, after doing that, you indicate on your diagram, where is the F? The F is 10 centimeters, indicate it there. Where is the C? The C is at 20 centimeters, also indicate it there. That's where the C is. So once you have done that, then you can go ahead and draw our object. Our object was at 20 and it was 2 centimeters high. Make sure that this line here is at 2 centimeters. Don't draw it as yet. Let me wait for you. Are you done?
Yes.
Okay. So you follow the rules. The first one says that a ray of light which is close and parallel drop from the head of the object. From the head of the object, it goes like that. Close and parallel. It goes through F.
So from here, I'm with you.
Yes? Stacy, you're saying? I've not heard what Stacy has said. So a ray of light which is close and parallel goes like that. And then it goes through F after reflection, like that.
Yeah.
Yes. You draw a straight line connecting the dots. Don't leave any gap. Then another one says that a ray of light which is starting from the object's head and passing through C. It goes and comes back. So where the two rays meet is where the image is formed. Let me draw another one which is not on a sketch, but for you draw one which is on a sketch, which is on scale, sorry. So in case I'm to draw this,
Wait.
you draw a straight line. For me, I've bent my line just to bring out the idea of where the image is. Use a ruler. So you can see this dot, where this dot is. At this point here, that is where the two rays have met. And if they have met there, then you can draw your diagram, your image from this point up to that point there. So this is what I mean. From this point, draw your image. So this one is your image. Just like it is on the sketch. Yes, are we through?
Not yet. Not yet. I'm just drawing the image.
Okay.
I'm done.
All right. We're now waiting for Ruben.
Hasn't he gone?
He's online, I'm seeing him.
Oh.
So in case you're through, okay, yes. So in case you're through, let's now answer the question. Part A was saying that determine the position. Use a scale diagram to determine the position. Part A. For part A, they want us to tell the image position. Where is the image position? In other words, what is the distance of the image from the pole? So I'm going to count the centimeters from this point up to that point. And from that information that we have, we can tell that our image position. 8 what? Remember that we're using our scale. So our image position is equal to
centimeters.
20 centimeters. So that is our answer for part A. You have just got it from here that this is 5, this is 10, 15, and 20. That is how you get it. That's how you get it. Then the next part was saying that calculate the image height. The image height is this height, this distance here. That is what they want. So from here up to there. And you can even use a ruler and try to estimate from that point there.
From where? From there to there.
From this principal axis up to this point here, where the image is.
4.
Is it 4? 2. is equal to 2 centimeters.
Meters.
Yes. So from this line here, that is the image height. So once you have got to that, then the last question was saying, of course, even another question may come that state the nature of the image. What are the characteristics of the image? One of them is that it is real. Why are we saying real? It is because we don't have any dotted line there. It is real.
Yes.
It is in front of the mirror. Another one is that it is inverted. It is upside down. Another one is that it is of the same size as the object. The object is 2 centimeters, the image is 2 centimeters. And then the last one, it is at the same center of curvature as the object. Okay, so the last part wanted us to tell the magnification. Roman 2, by definition, magnification is equal to image height let me use letters, height of the image over the height of the object. So which is the same as 2 divided by 2, you get your answer as 1.
Yes.
Yes, so that is the magnification. Or you can even say that magnification is equal to V out of U, which is equal to 20 divided by 20, you get a 1. So that is our answer. That is our answer. Now, I want to give you an assignment. 2 questions is,
For graph.
yes, on the graph. We are going to use the same question. Have we finished writing this information? Magnification?
Yes.
Okay. So using this same information here, using that same information there,
Yeah.
I want us to change this and put there 30 centimeters for my assignment. Yeah?
Yes.
Yes,
So for
teacher.
part A, just replace that. Then for part B, you also replace this. Put there a convex mirror for number 2. So the exercise
Where?
number 1. For the exercise number 1, just replace this 20 by 30 centimeters. That is my number 1. Replace the 20 by
Yes.
30 centimeters. Then for number 2, just use the same question for number 1 above and do it for the convex mirror. So when you're done, you simply you send me an image on WhatsApp.
Repeat.
I've said that for my exercise number 1,
Yes.
replace the 20 centimeters on that question by 30
Yes.
centimeters. Just that. You just copy and paste.
Okay.
But where there
Teacher,
is 20, put there 30. Mm-hmm. Yes, because you're saying something.
The first yes.
Exercise number 1. Okay, number 1, let me just do this.
Yes.
Let me do this.
Mm-hmm.
Uh-huh.
I was saying to repeat. I didn't understand.
Exercise. So that is my number 1.
Yes.
Cassidy, have we got it? On the same question that we have discussed. You can take a screenshot. Then, can you go to number 2?
Yes.
Yes. For number 2, just do this. For number 2, where there is a 30, put it there. 5. Still, you take a screenshot.
Let me write.
Then lastly, number 3. Can I go to number 3?
No, teacher, no. No, wait.
I have 5 minutes.
So I'm rushing. You know the meaning of writing?
No, you just write something small in the margin for that. For number 1, replace 20 by 30. For number 2, replace 20 by 5.
Yeah, first wait. So this is number 2 of your exercise.
Yes.
Number 1, you just replace 20 with 30.
Yes.
Okay. Now you can continue with number 3.
Then the last number, number 3. Number 3, we have number 3, I'm going to replace, I want to bring back my 30 and I'll remove this. And I wrote it there, convex.
So first wait. First we're repeating the question because those things.
So once you've finished copying, then that will be my number 3 and that will be the end of the lesson.
So what are you going to do for the
For the others, I'm going to send them a link and then they'll watch the recorded video. I have recorded this lesson, yeah? So whoever has missed, they will send me a request and I send them the video link.
diverging mirror? Okay. I'm done.
Okay, so if you're done, you can be looking at some of the terms that we use. What is meant by the focal point, what is meant by the center of curvature, what is meant by this, what is meant by this. Those terms, they're like around 6 terms. And just know their definition is, and that will be the end of it all. So allow me a good day.
So I want the work today.
I'm sorry, repeat again.
Today is when you do the work.
Yes.
You may, yes, you give me the work before the weekend, before Saturday ends.
Oh,
Before Saturday ends.
okay.
Okay, nice time. Tell whoever has missed to send me a link. I mean to send me a message on WhatsApp. Then I send the link.
Okay.